Welcome children. Let us do principle of reversibility of light from ray optics of class 12 physics. So what is principle of reversibility of light? Principle of reversibility of light. Reversibility of light. Principle of reversibility of light. What do you understand from this one? It's nothing but pair of media causing refraction. It can be A media, air media, and B media, glass medium. Air medium, glass medium. So XY is the interface separating one optical medium from another optical medium. Now I take a point of incidence and draw perpendicular line to the interface, and that is called normal. I take one incident ray, name it as AB or PQ, any letters you can use it, and it makes some angle I with the normal, and it undergoes refraction towards normal. Ray direction is very important, and that BC refracted ray making angle R with normal inside denser medium. Okay. Now it may undergo one more refraction through one more medium also, but at last when it goes from A to B, it is called onward journey. I can write mu of second medium, B medium refracts. So refraction is caused by second medium. So the refractive index of second medium, that depends on the first medium. So you can say refractive index of second B medium with respect to A medium. A medium has I value, B medium has R value. So you know sin I by sin R. So you can write sin I by sin R. Just for understanding, I wrote. It's a number, constant, you know, and other formula for this also you can understand. Now, I make this ray incident on any mirror. Can be concave mirror or something, plane mirror also. How you are keeping the mirror? The ray is making 90 degree with the surface of the mirror here at the point of incidence, mean it is called normal incidence, and it will be reflected normally. Again it will go back with that angle R as incident angle now, and again it will be refracted along BA. So it will go in the same path but in reverse direction. If there is any normal reflection by the help of any mirror or anything else also, to send it back in the same path. Now A, B, C is the onward journey when it came from air medium to glass medium. Now reverse journey C, B, A. Then when it goes in the reverse direction, A is causing the refraction, change in direction. Then mu of A with respect to B. Now B contains R, A contains I. Now you can write sin R by sin I. This I am writing for your understanding. Sin R value divided by sin I value. Sin R by sin I. Got it? Now what is the relationship between these two? If you multiply both mu of B with respect to A multiplied by mu of A with respect to B, sin I by sin R into sin R by sin I, you will get 1. So what is your conclusion? Mu of B with respect to A is equal to 1 upon mu of A with respect to B. That is the conclusion of principle of reversibility. What do you learn from this? I give an example. You know mu of glass with respect to air, that is 1.5. You know. Now, if light goes from air to glass, glass has refractive index of 1.5 with respect to air. That is also called as absolute refractive index of glass. Just refractive index of glass. But now I want to say, find out what is refractive index of air with respect to glass. Suppose light goes from glass to air. Then it is not called as absolute refractive index of air. It is called relative refractive index of air with respect to glass, which is 1 upon 1.5. This value is less than 1. This value is less than 1. So if you multiply 10 by 15, you will get 10 by 15. If you put 10, 100, 100, 7, 5, 7, 6 times approximately. So 0.6, 90, again 0.66 something you will get. So you see, the refractive index of glass 1.5 with respect to air, the refractive index of air with respect to glass is less than that. It means from the principle of reversibility you conclude refractive index of B medium with respect to A medium is the reciprocal of refractive index of A medium with respect to B medium. This one fact you understand. Like this you can form refractive index of water with respect to glass is equal to 1 upon refractive index of glass with respect to water. You can again make refractive index of diamond with respect to air is equal to 1 upon refractive index of air with respect to diamond. So in this way you learn from principle of reversibility of light. Okay, let us do lateral shift. What is lateral shift? Lateral shift, and this term you learn from a refraction through glass slab. A refraction through a glass slab. Glass slab. What is refraction through glass slab and the term lateral shift? Glass slab you all had seen. Make neat ray diagram. Glass slab, it is fully glass material, and we can name it as PQRS. PQRS. Air surface here, air media, it is glass media, it is glass. So glass means you can take it as B media also, it is B media. Air media is here also and here also. It is also A media. Air and which means glass. PQ separating air from glass, RS also separating air from glass. Okay. Now, I take in the left side one point close to P and draw a perpendicular line to PQ surface called as normal. Now, oblique incidence. One ray is incident at this point obliquely. Obliquely means I is not 0 or 90. I is maybe 30 degree like that. Name this ray as AB ray. Angle of incidence more than 0, less than 90, maybe 30. And this is incident direction. But it won't go because of glass changing the path from B to C. It changes along BC, this point. At the C point, again the air is changing its path away from normal, along CD. Now if you take, this is angle between a refracted ray and normal, that is angle of refraction R, and alternate angles, this R and this R. Again angle of incidence at the C point is R, equal to this R, and this is angle between normal and emergent ray, angle of emergence. So this I can say emergent direction, this is incident direction. So now there is some shortest distance called perpendicular distance between incident direction and emergent direction. This normal perpendicular line it is. So you can say this CE also you can say, because we are using A, B, C, D, E like that. So CE is a perpendicular normal line to the incident direction, means that is the minimum distance between the incident direction and emergent direction. That minimum distance only we call it as lateral shift. We will talk about lateral shift later on, but now we have to prove that when a ray is incident obliquely on a glass surface in air medium, it emerges out of glass surface. The emergent ray is parallelly shifted from the incident direction. Got it? How do you understand it is parallelly shifted? Because this angle of emergence is equal to angle of incidence. If you prove that, it meaning the emergent ray is parallel to incident direction. So that proof we have to do. And the minimum or the perpendicular distance between emergent direction and incident direction is called as lateral shift. Lateral means parallelly shifted. Parallelly shifted, and that minimum distance between incident direction and emergent direction is called as lateral shift. That lateral shift depends upon what later on we will do. Now let us prove that emergent ray is parallel to incident ray and it is shifted on the left side of incident direction. So here you can say there are two refraction taking place. The first refraction, when the light goes from A medium to B medium at the point B. So you can write at B, light travels from air to B medium means I in air medium or in B medium. So Snell's law says sin I by sin R. And at second point, light travels from glass to air. It means light travels from glass means B medium to air medium. So air medium is refracting. Its refractive index with respect to B medium, and B has angle of incidence at C point R and angle of emergence E here. So Snell's law says for the second refraction sin R by sin E, sin R by sin E. So you know very well mu of multiply both mu of B with respect to A into mu of A with respect to B. This is nothing but 1 upon mu of B with respect to A. So this gets cancelled means 1. So if you multiply these two on this side, 1 you are getting means right side you multiply sin I by sin R into sin R by sin E. Here also sin R gets cancelled. So 1 is equal to, you will get sin I by sin E, which says sin I is equal to sin E, which says angle of incidence is equal to angle of emergence. So if I allow oblique incidence with angle of incidence 30 degree means angle of emergence is also 30 degree. This you can perform an activity with the drawing board, drawing paper, glass slab, drawing pins and taking angle I as 45 degree, you will get R less than 45 degree. Here again, this angle you will get 45 degree. So angle of emergence is equal to angle of incidence means the incident ray after refraction through the glass slab emerges in such a direction. The emergent ray is parallel to incident direction because angle of emergence is equal to angle of incidence. In the same thing, you can prove what is this D. It is equal to thickness of the medium means P2R. P2R, that is thickness of the medium, I can say T into sine of angle of incidence minus angle of refraction divided by cos R. This we can prove. How to prove? Let us take again here. If you take this D distance, it is opposite side of this angle. This angle is I minus R. This angle is I minus R. So opposite side of I minus R is lateral shift. What is lateral shift? The minimum distance, shortest distance or the perpendicular distance between incident direction and emergent direction is called lateral shift, and this angle is 90 degree means BC is hypotenuse of the right angle triangle BBC. So let me extend this normal also like this. So this angle is I minus R. So D is opposite to the I minus R, means I can write sine of I minus R. I need opposite side by hypotenuse is BC. BC. So what is this? D is equal to BC, hypotenuse of the triangle into sine I minus R. So we got sine I minus R. Now this BC in terms of this PR, B name this point as some F. So PR is thickness of the slab, glass slab, thickness of the medium, means it is equal to BF. PR is equal to BF. So now let us take the hypotenuse along with R and along with BF. So we can make the equation cos of angle of refraction is adjacent side divided by hypotenuse. Adjacent side is nothing but thickness of the medium. Hypotenuse is BC, which gives BC is equal to cos R by T. So if we substitute in this lateral shift, BC is equal to T by cos R into sine I minus R. Let us take this cos R along with sine. So this is called lateral shift. And it is nothing but distance, can be 2 centimeter or 2 millimeter. So what are the factors on which this D depends? D depends on thickness of the medium. D is proportional to thickness of the medium. And D is proportional to angle of incidence. If I change it from 30 to 40, this D also will increase. On increasing this angle of incidence, the lateral shift value also increases. What other factors on which this D depends? For glass, if we get 3 centimeter means, for diamond, we get more than 3 centimeter. For water, in the place of glass, if we take water, we'll get less value. So refractive index more. Diffractive index tells about optical density of medium. Diamond is highest density medium for which refractive index is very high, optically denser. Optically denser, you have to say. So it also directly proportional to mu, refractive index. So if it is water, this D value may be 1 centimeter. For glass, D value may be 1.5 centimeter. For diamond, it may be 2 centimeter or in millimeter also. I am just giving some example for making better understanding. So more is the density of this media, more is its refractive index, more is the shift between incident direction and emergent direction. So in this, it's very important aspect. If you increase I value from 10 degree, 20 degree, 30 degree, 40 degree, E value accordingly will become equal, but this D value will increase. I value increases, lateral shift will increase. Thickness of the medium, if I take this much thickness, if this is this much thickness, D value will be less. If this is this much thickness, lateral shift is more. That's why these 3 points you must remember along with this formula. So now in this session, you have done what is meant by principle of reversibility of light, mu of second medium with respect to first medium, or mu of B medium with respect to A medium is 1 upon mu of A medium with respect to B medium. Mu, I gave many other examples. And what is lateral shift? Parallelly shifted emergent ray from the incident direction. The minimum distance between incident direction and emergent direction directly proportional to thickness of the medium that refracts, and directly proportional to sine value of I minus R means directly proportional to I value, angle of incidence. And cos R you need not mention because R value depends on I value. D depends on I means you need not say D depends on R. And D depends on T, D depends on I, lateral shift depends on refractive index of medium. How? Directly proportional. On increasing all these values, D will increase. That is called directly proportional relation. Let us still do interesting topic after this session, next session. Thank you. Next class.